my background is in naval architecture and ocean engineering. And actually, I became a member of RENA back in 2009, in my second year of university. So I just realized just a few minutes ago that it took me 11 years to reach the headquarters, but I finally made it, slow and steady. But yeah, let's see. So the agenda for today. I wanted to take a step back from the paper that I wrote and give you a broader overview of what I'm working on, and especially look into the human factors problems about shore control center design. And I'll let you know what a shore control center is. It has to do with autonomous ships. And then I want to talk about interaction design. This is the area of my PhD research, and essentially how interaction design can be used as a way of addressing human factors problems in a practical way. But a little bit about where I came from yesterday, NTNU, Norwegian University of Science and Technology. What's special about this university is that we've got 10 years of experience in the field or the area of maritime autonomy. So this is sort of this has become a hub of this new research area, which is autonomous shipping. And there's a really strong link between the university and between startup business culture and established big industry, and with research institutions like, for example, SINTEF and SINTEF Ocean. So it's a good place to be if you're studying marine autonomy, like I am. So this is a picture that I took in November at the IC MAS conference in Trondheim. The IC MAS conference is the International Conference on Maritime Autonomous Surface Ships. And the reason I wanted to show you this is because it shows you what autonomous ships look like. They're really just test boats right now. We haven't really gotten that far with marine autonomy. So here, these two white boats here. These are Kongsberg Seatex autonomous boats. And this little blue contraption here, this is part of what's called the Auto Ferry project at NTNU, which is they've designed an autonomously running ferry for the canals in Trondheim. So it's really pushing the boundaries of what's possible here. But now about my research, the way I summarize it is autonomous with an asterisk, because the problem with marine autonomy is that it's not really fully autonomous. We still need humans, so this is a nice segue into this human factors conference. So just to give you some background, levels of autonomy are generally divided up in a table that might look something like this. This is adopted from the SAE International guideline on levels of autonomy, which is generally used for road traffic or like trucks or cars, but it applies also for ships. And the Norwegian Forum for Autonomous Ships has also adopted the same guideline. So it goes from level 0 to level 5, where level 0 is no automation, 5 is full automation. But can anyone hazard a guess on where we are today with the most advanced marine boats, marine autonomous boats? We're at level 3, pretty much. So it's conditional automation. So this means that navigation is automated, environment sensing is automated, but critically this control fallback, it relies on humans to deal with these unexpected situations that are outside of the programmed algorithms. So not all modes are autonomous. We still need people to deal with these outside events. And a lot of people, especially technically inclined people, they sort of assume that if you increase the amount of autonomy in a system, you end up with safer and more efficient systems because you're removing this error-prone human who makes mistakes, and you're substituting it with a computer that makes no mistakes. But actually, there's about 40 years of literature that shows that this is not the case. Just because you increase automation in a system does not make it more safe, does not make it more efficient. It just generally increases or introduces new ways for things to fail and new mistakes to be made. So the hypothesis of my research work is generally this: autonomy plus user-centered design might equal safer, more efficient systems. And I'll get into what this user-centered design is all about. But first, what is a shore control center? I've been sort of talking about shore control centers now as if I assume you know what they are. But the truth is, I don't even necessarily know what they are. Shore control centers don't exist yet. They're still in the designing phase. There's lots of prototypes that are being built and lots of visions for what a shore control center is. But I've been tasked in my research project to help design the first one running the commercially operating ship Yara Birkeland in Norway, along with Kongsberg Maritime. But shore control center, what might it look like? Well, there's this vision here, which is somewhat infamous now. This is a Rolls-Royce vision for what a shore control center looks like. They published this video in 2016, and it shows a very stern Finnish captain, and there's like drones flying around, there's holograms, and very high-tech stuff. And he's operating this ship, or he's checking up on the systems from a shore control center in Finland. This doesn't exist. It's just a sci-fi type video. And this is the shore control center that we built in Trondheim for the auto ferry that I showed you. So we managed to get a 5G link from the ferry to the campus. We set up some 2 screens, got a computer, and one day we managed to set up that little shore control center where we can take over manually and see what's happening on board this ferry. So now we can start to build a model of what the shore control center is. So it's kind of a control loop where you got this autonomous boat, which is sending lots of data to shore. There's people working there. They're building situation awareness, which they can then use to safely supervise, monitor, and intervene with, if necessary, the control of this ship. This is the prototype that I get to work on with Kongsberg Maritime. This is a picture that I took just last week when I was down in Kongsberg in southern Norway. On the left here is Jon Bernhard Høstmark. He runs the Shore Control Center lab down in the Kongsberg Maritime office. And so this is his baby. So this is what the current prototype of a shore control center looks like. So it's essentially a desk, chair, computer, mouse, keyboard, standard. There's also this joystick here on the right, coffee cups, of course, and 3 screens showing various types of systems, onboard systems, which I'll tell you more about what's on the screens a bit later. But this hopefully gives you an idea of what the Shore Control Center physically looks like. It's uniquely positioned in a way that, let's say, traditional shipping, ship management isn't, because what we find is that the people who are interested in owning maritime autonomous surface ships, what they really want is like a larger control of a wider distribution network. What they're really interested in is getting their cargo from point A to point B in a predictable way. So this means that the Shore Control Center, it's expected to also have communication with not just vessel traffic service and port center, but also transport logistics, or the container terminal, or packing facilities, the whole spectrum. And in the middle of this is this guy up here, the operator on the Shore Control Center. So this helps to underline how important it is to nail down the human factors elements when approaching the design of the Shore Control Center, which is why I came to this conference. So that brings me to human factors problems. I wanted to suggest to you 3 human factors problems that exist in the Shore Control Center. So this is a picture from the Kongsberg Shore Control Center lab. On the left here, we've got this supervisor station. On the right, we've got two operator stations, operator station B, operator station A. And at each of these stations on the right here, operators are expected to deal with more than one ship at a time. So there's a multitasking human factor problem here. Because the whole business case on autonomous ships in the Shore Control Center really depends on control of more than one vessel to make it all worthwhile. So here's another view of that room. Supervisor and the various operators, each with their ships that they're managing. And right now it's hypothesized that one operator can handle 6 vessels. But actually, this number was suggested by the Moonin project, which actually my supervisor, Dr. Thomas Prata, was heavily involved with. And this number was suggested, but it hasn't been formally tested yet. We don't really know how many ships one operator can simultaneously manage, but it's got to be more than one. Situation awareness. This is another important human factor element that we're looking at. And the way I define situation awareness is the same as Mika Ensley defines it, which is just the ability to gather information and understand its meaning and project that into the future. So that sounds very theoretical, but it's pretty simple. If you can imagine, an example might be you're driving your car and you see a yellow light. Maybe it's dark and it's raining. Gathering all that information is one thing, but you need to understand its meaning. You have to understand that this means that you need to stop before the light turns red. Maybe there's a car behind you. You can't stop so fast that the car's going to rear end you. And you need to be able to make that mental calculation and project into the future to make a decision. Am I going to slam on the brakes? Do I have time to make the red light, or do I just safely proceed through? So that's a basic example of what situation awareness is, and humans are making these calculations all the time. And it requires having enough information and having the context to understand how to make a good decision. So we need to design for situation awareness in this Shore Control Center. Skills, another thing that inevitably comes up. What skills do humans need in the Shore Control Center? And one thing that comes up again and again is people think that maybe it doesn't need to be a certified mariner. Maybe we can have someone who's got more of what I call gaming skills. A little bit controversial, but the overlap is probably where we are going to find ourselves in. But defining that overlap where there's gaming skills and marine navigation skills, this is also a question that we want to look at. And of course, experience plays a really important role here as well. Oh yeah, and intervention. I would be remiss not to mention intervention because it changes everything. Because this is like the only active control that is expected to happen in the Shore Control Center, where the rest of it is passive, just passive monitoring, passive supervising. So intervention changes everything. It changes the multitasking component because you can only intervene with one boat at a time. So how do you hand over those other boats you're controlling? And in terms of skills, you need special training in this area, and not just training, but the ability to retain those skills. And for situation awareness, there's a risk here of being out of the loop, it's called, or the out of the loop phenomenon, which psychologists seem to call it, which is that you don't have enough information to have the situation awareness to be able to make wise decisions. So you can imagine if you're supervising these ships day on, day out, and then suddenly need to intervene, being dumped in that situation can be quite demanding. So I want to talk a little bit about interaction design. So this is the area of my PhD. But I think actually interaction design and human factors have a lot in common because both are concerned with the natural abilities and capabilities, not of technology, but of people, of the users who are using the technology. So a little bit about my project. It's called LUAS, which is the Norwegian acronym for land-based monitoring of autonomous ships. And the goal is to develop and test interaction solutions for the Shore Control Center. And this is fun because this project was just kicked off officially just last month. So this is the first time I get to kind of talk about the project and test out some ideas with you guys. So I'm hoping for some comments in the question period. But the project is being led by Kongsberg Maritime, and we've got two partners, Masterly and DNVGL. And Masterly, if you haven't heard about this company, it's a pretty new player, and it's a joint venture between Kongsberg Maritime and this ship management company, Wilhelmsen, and it's specifically established to be an autonomous ship management company. And the first ship they have is the Yara Birkeland. So this is the new autonomous ship that is planned for operation in 2021, the world's first commercially operating autonomous ship. What we plan to do is, here's some themes. User-centered design is a major theme. So instead of seeing what we can do with the various technologies, we want to work with the user, with the remote operator. We're going to do goal-based task analysis to really enumerate what's expected of this Shore Control Center operator in terms of his day-to-day job. We're using information visualization to really enhance the situation awareness in the Shore Control Center. Of course, measuring human performance, this is a really important element in the whole project because it's how we can find out how well they're interacting with the technology. And a key thing to note with this project is that the innovation lies not in creating new technologies, but just in integrating existing ones. So all that fancy software you saw on that screen I showed you, that's all built from existing technologies. So I wanted to give you some quick examples of what I'll be doing as an interaction design researcher in this project. These are just ideas that I hope to do. So keep your eyes and ears open because I'm essentially testing out these ideas on you this afternoon. So one thing I want to look at is this number of ships that this operator can handle simultaneously. What happens in terms of multitasking? How can you divide your attention up between more than one ship? Is it 6? Is it 2? Or is it just 1? This is one thing that I want to look at. I'm especially interested in actually measuring the workload jump from 1 ship to 2 ships, just to see what that workload difference is. Situation awareness, particularly interested in that time component in the handover. So, for example, there's been studies in autonomous cars, where they say that the handover time is 6 or 7 seconds, but they've got their hands on the wheel and they're moving with the car. And by the time it goes from autonomous mode to manual mode, by the time they're comfortably situated in the moment, 6 or 7 seconds have passed. But what about in the Shore Control Center? How long does it take? We don't know yet. Just takes 7 seconds? Probably takes more, but how long? It's an important thing to address. And this skills component, what skills are needed? Really interested in this overlap area between the gamers and the marine navigators. I would love to get a bunch of Fortnite players into the Shore Control Center and have them run scenarios and measure them on various cognitive tasks and compare it to trained marine navigators to find out. Controversial maybe, but really interested if we can nail down and maybe throw out this gamer side altogether, or at least test it. Because one thing's for certain, and that is that this is not a traditional marine navigation situation. And intervention, can we supply the remote operator with tools to have better situation awareness in intervention mode? So some basic ideas are introducing haptic feedback, or like a better feel for the ship. So a lot of the feedback I've heard so far is that a ship captain feels the vibration in the engine, and they can smell the salty air or whatever, and which is of course really important. But how can we get that into this shore control center? One way is basically just having the stick shake like the engine shakes, perhaps. So we want to play with that idea. Mode status seems obvious, but it needs to be really clear that you're gone from automation mode to manual mode. When you're operating more than one ship at a time, you generally see this top-down screen that you might see in, like, say, a VTS, vessel traffic service software. But when you're in intervention mode, you need to go into what I call a street view, or Google Street View mode, so which looks like this. So now you're in a ship, and now you're virtually in the bridge, and you've got your charts and your ECDIS and your radar, and you can begin to understand the situation from that ship as if you were on board. And that's the end of my presentation.